didn't load.
Episode something.
Have a good podcast.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 118. Today we're talking about the Apple AirTag that has been hacked, 3D printing Infill without perimeters, hair-pulling robots, and unpacking the 555. Elliot, I'm excited that Kristina Panos is joining us today. She'll be talking about her Inputs of Interest series a little bit later in the show. But for now, let's jump right into the news. This week, I wanted to talk about a project that one of the Hackaday contributors, Anul Mahadharia, has been working on at his hackerspace in India. It is a project to build oxygen concentrators to help combat the shortage that's going on in India right now due to the COVID-19 pandemic having another wave there. Makers Asylum has been working with an open source project which is called OxyKit that uses zeolite, a highly porous alumosilicate mineral that performs the task of molecular sieve. So basically, you're pumping air over this, and through the sieve goes the oxygen molecules, which then can be further concentrated to the point where they can be used for supplemental oxygen.
Yeah, this is a really cool video and explanation of his. And I guess the reason they're doing this is to make it obvious to people who want to DIY one themselves that it's not so hard as you think. And it really, really isn't. You pump it over hot zeolite. The zeolite absorbs, maybe adsorbs, I don't know. The zeolite sucks out the nitrogen from the air. And so basically, it's not so much an oxygen concentrator as a nitrogen removerator. And it goes back and forth between these tubes. It absorbs the nitrogen, and then you heat it up and it drives the nitrogen off. And then you go back and forth cycling through. But you get rid of most of the nitrogen in the air, you've got a lot of what's left, which is basically oxygen. So in that sense, it's an oxygen concentrator. It's not like a respirator where it's directly in contact with a human being.
Right.
And so you're going to hurt somebody if you blow out their lungs with it. This is kind of a simple to make chemistry thing. And, you know, there's a bunch of fine details, how high you heat things, how finely you need to grind the zeolite. But again, this stuff, as the title says, isn't rocket science. If you need to make your own oxygen concentrator, it is the sort of thing that you could possibly do.
Also new this week, there is a contest that is running over on Hackaday.io called the Reinvented Retro Contest. This is, I guess, exactly like it sounds. Take something modern and make it look retro. So that could be like putting it inside of the case for retro. I was actually thinking about this, Elliot, like we're only looking at the winners of yesteryear, right? Like there must have been a lot of really ugly stuff, you know, back in the 1960s or choose your decade, but we like glamorize the best of it.
I think we see a lot of the ugly stuff too, and we just like rose-colored glasses it into being quirky and awesome.
Right. So if you have an ugly duckling that's your favorite, go for it. But
Exactly.
Otherwise, yeah, just make it look cool. That's the point of the contest. This one is sponsored by DigiKey, and they're putting up 3 shopping sprees of $200 to their in their warehouse, so you can get some a good component haul that way. And I'm looking forward to seeing what comes out of this one.
All right, can you hear this, Mike? It is the sound of a 555 timer blinking an LED.
I wondered what that low frequency hum was.
It's time for the winners of last week's inaugural What's That Sound contest. First, I'll play a little snippet of the sound. It's too late to submit, but here you can rack your brains and feel bad about it.
The ASR33 is a mechanical teleprinter of the Teletype brand, a name which pretty much became synonymous with the machine. This model, introduced in 1963, worked with the then brand new ASCII standard.
Right answers range from the right to the extraordinarily right. A lot of people just said teletype or teletype machine, and I was totally happy with that. 2 people said ASR33 teletype, so they got the model number.
Oh, I think 3 people said that.
Oh yeah, 3 people said ASR33. Holy cow. And the honorable mention for most specific goes to Bob Coggeshall for ASR33 teletype, 110 baud, including a line feed and a carriage return. What the heck?
How did you do that, Bob? Which is exactly the email that you sent to him.
So I had to send him an email saying, what the heck? And he's like, well, it's cheating. They're all 110 baud, and you can hear the carriage return. So yeah,
that
fair
must
enough.
be a rhythm. That must be a rhythm thing, right? The carriage return and line feed.
You know, it's got one of those little, it is like a Selectric typewriter, which is one of the answers that we got a whole ton of with those ball heads. So it does kind of have to go all the way to the end and then slide all the way back. So you can hear the carriage return. We got a number of not quite right answers, including punch card related answers, which isn't totally false because this thing does have a tape puncher running down the side in parallel with the printer. And at some point in time in the sample, I think toward the beginning, the microphone's closer to the tape puncher than it is to the print head. But I made sure to get a sample where it was close to both of them, so you can hear both running. But all you people who said punch carder don't feel so bad. You were like half right. And the people who said Selectric golf ball printer, you were also half right. So kudos to all of those answers. And we got two absolutely superb, ridiculous answers, one of which from Norm Rasmussen, Lyrebird imitating a chainsaw from David Attenborough's BBC shows. Pacholek Arthur, it's a mechanical calculator trying to divide by zero, the poor thing.
Oh no, now we're going to be inundated on future contests with
That's what I hope. I'm totally stoked. I'm totally happy. I hope so.
Nice.
I said I was going to make some kind of Rube Goldberg random number machine and then didn't get around to it. So what I'm actually going to do is run Python random uniform and round. So mea culpa. I actually have no idea how Python random uniform and round deal with the edge cases. So I'm actually going to run this number from 0 to 15, see what we get. And if it's out of bounds, we'll just do it again because I don't want to have to think about when it's rounding up and when it's rounding down. So drum roll, please. 12.
12.
Which is, number 12 is, it's raining Hackaday at PM.me, teletype machine. All right, we have a winner. Congratulations, it's raining Hackaday. We'll shoot you an email, get the sizes figured out, and take it from there. Rest of you, listen up. Next week, we will have another What's That Sound challenge to amuse and delight.
All right, enough with the preamble. Let's get into our hacks of the week. Elliot, what's your first pick?
My first pick this week is a 3D printing hack, and it's kind of two hacks in one. 3D printed desiccant container exploits Infill. And the thing I really liked about this is the idea is to make a box that's breathable so that you can put dehumidifier salts in it and, suck the humidity out of the air. The Red Coat has done it by removing the outside perimeter from a 3D model and just printing that kind of lattice-like infill structure. And it's awesome. It makes a little permeable membrane. It looks almost like a woven basket or something, except it's 3D printed. I love this because I think the people who wrote the slicer were not expecting you to just remove the perimeters and just have the infill, but they didn't bother to prevent it. So, go nuts. If you can find a use for it, you can do it. But then the second hack here that I really liked is the fact that it uses Slicer and Prusa Slicer's ability to do modifiers. So you can take two different models that overlap and have it change the properties where they overlap. And so, for instance, this one, he wanted to have solid pillars on the four corners to hold the thing up, and I guess on the floor too. And so there's a model that overlaps where he wants to get rid of the perimeters. That is such a powerful technique. It's something that I want to see people take advantage of more than they are. So that's the whole reason I'm bringing this up, is because I think this ability to control the infill in your print, control what's going on the inside of your 3D model, is something that's hard to do in other means, and it's something that's going to be particularly useful. And in this case, he's doing both of the models, both the box shape and then its modifier in OpenSCAD. And because that's parametric and just simply programmed, it's super easy to describe the modifier shape as well. And so if you look through his code, it's dead easy to make this like kind of complex shape that is missing perimeters here but has perimeters there and stuff like that. Really, really cool technique.
I was surprised that it hung together like this. I would have thought that you needed the walls in order for the infill to not be like floating, like free floating.
Right.
And be like between layers especially. And then the other thing, I don't know, maybe this is wrong, but instinctively I look at, especially there's a picture on the Thingiverse that shows you a kind of a better profile of the infill from the side. And it reminds me of like electro-spun fibers.
Yeah, right? It's a super cool looking pattern, huh?
Yeah, I think it is. And I mean, like usually the opposite is what you're trying to do, right? You're trying to print something that'll hold liquids.
Right.
What are the other cases where you need like a breathable thing? I mean, this could be like a cover for a grate for heat to get out. I mean, maybe it's too dense for that. I mean, what?
You could 3D print speaker grills.
Right.
I don't know. There's all of those fan things. I guess you don't want to do it necessarily with infill. I mean, most people model grills and stuff like that by just like putting a lot of holes through it instead of this kind of three-dimensional web-like thing, right?
I would think that silica gel is not dimensionally accurate. So you
Right,
probably
there's
do
little
need,
balls.
yeah, you do need something like this because you don't know how big or small necessarily the grains are going to be.
Yeah.
That's pretty cool. It makes me wonder though. I have one of those. I mean, it looks like the same silica gel stuff. I have one of those that you can toss it in the oven and
Right.
it'll like dry the silica out. So I suppose with this you just crack the top of it off and put it on a cookie sheet and bake it and reuse it again.
Pour it out and pour it back in, I think. Yeah, it's a really cool design. We've seen some slicer modifier hacks before. Like I said, I want to see more. One we saw fairly recently was from CNC Kitchen, was doing some finite element analysis on his hooks and figuring out where they needed to be stronger, and then using the modifiers to make the infill solid where they needed to be stronger. So the kind of opposite application of this is to beef up the interior of 3D prints, and I think that's actually really strong. And a long time ago now, in 2016, Garrett Coetzee wrote us an article on a look into the future of slicing. And here he's got not just modifiers, but ideas about how you could use these modifiers to say to the slicer program, this part is structural, this part is decorative, this part needs to be dimensionally accurate, this part doesn't, and have it do significantly smarter planning of not just the infill, but also the perimeters too. And I think that was an incredibly forward-looking vision of the future of slicers for 3D printing. And that hasn't come to pass yet. And so you can make your own little stabs at the future by using these kind of modifier techniques like the Redcoat did in this lovely hack here.
Well, the big news in the Appleverse lately has been the AirTag, which is a Bluetooth beacon. If you know of that locating product called Tile, it's kind of like that, but it's from the Apple Corporation. You know, it looks great. It's got that wonderful industrial design on the outside. It's got a little CR2032 coin cell in it, and it does exactly what they say it does. But the interesting thing for us is what's inside of it and how many of the secrets can you unlock. This is something that the research community jumped on right away, and we started to see some fruits of that labor last weekend, especially from two researchers, Stack Smashing and Colin O'Flynn. Colin had been working to drill down on the design of the board itself, identifying all of the parts that are on it and tracing out the circuit board to unveil what the test points are and what's going on with it. And Stack Smashing took that and ran with it, using a side channel attack in order to circumvent the locked debug mode on the Nordic semiconductor chip. It's the NRF52832, which is a very common chip to be on these kind of Bluetooth devices. Stack Smashing was able to dump the firmware that's on it, change some data on it, and then flash it back to the chip, because the write protection is on there, so you can't read out the firmware, but you can write it back to it, and turned this tag into something that when you scan it with an NFC reader, it will send you to your favorite YouTube video. Never gonna let you down.
The star of the show here for me was the way Stack Smashing got into the chip at all, because like you said, it is write protected. And if you want to dump the ROM out of it, you have to figure a way around the bypass. And this is why I love you open source security folks out there. He was able to draw on work done by Limited Results, who had done some voltage glitching against this chip before, and essentially re-implement this procedure, target this particular device, and Bob's your uncle. A lovely bit of work, though, and great documentation of it.
Yeah, we actually saw a video on Tuesday night. Stack Smashing put one out on YouTube. You should go and check it out. It's a good one. There is a great description, kind of high level, at the way that the voltage glitching was done on this. It was actually done with a Raspberry Pi Pico board, which is something he's been working on as a little tool for all kinds of things like this. But by patching into one of the voltage traces on a decoupling capacitor going into the chip, he was able to short that to ground and basically brown out just the processor core that's inside of the chip, and put some automation on it so that while the thing was powering up, he would try different glitches, different lengths of time for the glitch, and starting at different times. This is not his first rodeo. A few years ago, he did this with the exact same chip, so already knew kind of exactly what the best parameters were going to be. And I think said it only took a few minutes of this automated process. So that basically the Pico would do the glitch, and then a separate programmer would try and load the debug shell. And if the shell loaded up, then it would stop and pause for him. Then he would know he's in there. You only need to do it once, because once you get into that debug shell, you can pull down all of the firmware off of the chip, and then you have a good copy of it, and then flashing it back to the chip is really easy. Details are still kind of coming out. Colin O'Flynn was working on dumping the SPI flash and did that, like a week ago now. That SPI flash has a bunch of interesting stuff in it. It sounded like it actually had the firmware on it. So, like an ESP32 will pull the firmware off of an attached EEPROM at boot. And it sounded like that was what was happening. But then looking at this news from this video, it looks like that was not the production firmware. It was some kind of like debugging firmware, and what's on the chip is what you actually want to get at for this.
It's super cool. The other reason you'd want to hack into this thing is it's got whatever that fancy new Apple chip is on it over in the corner. And that makes this potentially an interesting dev board for playing around with that. But that part of the AirTag hasn't really been dug into yet. So I think we'll be seeing more of this in the near future.
And of course, it's just kind of a where are they now? I always am happy to see Colin O'Flynn doing fun things, because he developed the Chip Whisperer, which took second place in the original Hackaday prize back in 2014. Not surprising to see him pop up poking around on some of the most interesting consumer hardware that's out there.
My next hack is improved graphics to drawing tablet conversion. Akaki Kumeri wanted a fancy drawing tablet, and if you've looked around, the tablets that professional artists use to draw is the Wacom Cintiq, which is a tablet that you can draw on with a special pen, but it's also got a screen over the top of it. And these are targeted at high-end artists and have an equivalent price tag ranging kind of between $500 and $2,000 to $3,000. If you want to instead take an old tablet that doesn't have a screen on it, add a screen to it yourself, it turns out you can. And Akaki's doing that for us in this video. It's a lovely combination of kind of just taking some simply available things. He uses the Retina screen from an old iPad, which is a nice screen with high resolution. He makes a beautiful 3D printed frame, gets some glass also from an iPad, puts that over the top of it, and then just basically lays this thing down over the Wacom Intuos 4 tablet, for those of you playing at home. The one trick here is that the screen is backed with an aluminum foil backing, I guess to prevent electromagnetic radiation from going through it. And of course, that's exactly what the little pen that goes along with the Intuos tablet needs. So he has to carefully remove this aluminum shielding off the back, and he demonstrates that in the video with kind of Finnish understated humor, mentions that he ripped the little wires off of one of them in his previous attempt, and shows you how to do that without ripping it up this time. But basically, there's nothing super hard here. It's buy a used display, buy that display's HDMI converter, make a beautiful custom formed 3D printed frame for it, slap it on your drawing tablet, done. And you've got something that's the equivalent of one of these high-end ones for like $100.
Yeah, I don't think this is easy at all. I think we're really underplaying the ability to delaminate that stack up for the screen without screwing stuff up. Like that's some witchcraft right there. Who was it that did that volumetric display with the transparent OLED screens?
Was that Sean Hodgins?
Yeah, it was Sean Hodgins. So that was a hack that happened not too long ago. And I look at that and I'm like, that's really cool. Like, can I take any OLED screen and make it transparent? And the answer is no. Like you go and you look and there's tons of people who have tried removing these lamination stack ups and it just ends up hosing the screen. So the fact that this one worked at all is awesome.
But he doesn't have to take that much of the stack up out. I mean, this thing's still backlit. The backlight's still in there. All the funny diffusers are still in there. He's actually just peeling a little glued on aluminum foil off of the back so that it doesn't do EMI problems. He's not actually looking through the screen.
I didn't get it that the backlight was still on there. I was thinking this was like an OLED display, so the pixels lit by themselves. And now for something completely different. What if you were unable to brush your own hair, Elliot?
I would have scraggly hair. I'd probably shave it off.
I think this is a really interesting look at a legitimate problem. So if you want to talk about people living independently into old age or people that have disabilities living independently, you don't usually think about the ability to brush your hair as being part of it. But obviously it is. Like something that is so simple in most people's everyday lives can be a real letdown for someone who's trying to live independently and has a disability that prevents them from, that small everyday task. And so this research project looks to see if a robot arm can be tasked with brushing long hair. And this is almost the stuff that nightmares are made of, Elliot. If you think about kind of a regular trope on movies of people's bad childhood, a lot of times you will see like the brushing of long hair as being one of those moments that's really not good. And that's when a human's doing the brushing. How do you train a robot to do that? And part of the answer here is to use machine vision and the ability of a computer to take a picture of the hair that's about to be brushed and then glean some information that could be useful off of it is key in the research that was done by Josie Hughes and a few other researchers out of MIT's CSAIL program.
I think this one was lovely because it pointed out how hard some of these apparently simple problems are. And like we think of robots doing everything for us in the future, but then like some of these problems are just much more involved than you would think at first blush. So like they're getting in there and analyzing where the hair's already straightened out and where it has tangles using computer vision. And then they're trying to not rip it out of the person's hair by pulling too hard when it gets stuck. There's all sorts of finesse here that makes this an incredibly difficult problem and kind of the ideal test bed for this idea that we could have robots in the home helping take care of us like this. That's why I loved Kristina's title for this. MIT's hairbrushing robot untangles difficult robotics problem. Get it? Untangles? It focuses on the other reason you would want to do this research, which is not just to help people who can't brush their own hair, but also to start down the road of tackling these nearly impossible robotics problems that maybe seem a little bit too simple on the surface.
I think one of the interesting parts for me is that they would give a brush that had a sensor in it that would, if it gets snagged on a snarl in your hair, it'll know.
Yeah.
and it won't just continue to pull those so hard. Although Kristina did mention it would be better if the robot was able to hold onto the hair and brush below where it was holding it.
Right.
Which I think is what you do. And she also mentioned, like brush out the ends of the hair first. So I think that there's some process, but that's in the future. This is a good, interesting start. And in part of the training, they give that brush with the sensor on it, this I guess snag sensor or tension sensor or whatever you want to call it. They give it to a human and have them brush their hair while they're recording the information. And so it is interesting to think about like training some of the, what's going on in, I guess, time-tested hairbrushing and trying to incorporate that into this. I do think, if you go and read the paper, they talk about other things that have already been automated. And I went and looked at those, and some of those projects are, more than 20, like 25 years old. And one of them that they mentioned was shaving. And I'm like, oh no, you can't have a robot shaving. It's like a Remington shaver. It's like the electric shaver, right? So like, okay. Like that is not nearly as hard of a problem because you already have that really difficult engineering thing solved, right? You already have like an automation for shaving in the electric shaver, like the same for toothbrushes, right? So it's just a much easier problem to deal with because if you have an electric toothbrush that vibrates, you can have teeth that are in, you can tell where they're in the same place. The head might move a little bit, but like the teeth aren't going to rearrange themselves. But like every time you wake up, your hair is in a different state. It'll never be in the same state. It's like the ultimate entropy on the human body.
I bet you toothbrushing isn't all that easy too. Does it like clamp your mouth so that you can't move around? Like I brush my son's teeth sometimes and he's a wiggly little monkey and like trying to get in there, you can't see because of all the foam. So like you can't use computer vision. I have to somehow intuit where his teeth are. It's not as easy as you think.
You're not brushing teeth on an inanimate object. Like you know what teeth brushing should be, and so you would hopefully be cooperating with the robot that's helping you.
Anyway, I think a lot of these are significantly harder problems than they appear at first blush, right? At
first brush, of course.
At first brush. Oh, that was good.
Oh,
accidental.
At any rate, it's another one of those examples of difficult engineering kind of hiding in plain sight. Like, I don't give two thoughts to how I'm combing my hair, even though I know that every time I do it, it's a little bit different. Like when you start to think about it, like there's a part that sticks up here that didn't yesterday. And you're like, why is that like that? And finally you're just like, well, it's good enough. And you leave. And then the next day that spot isn't like that anymore. It's very different every single time. And looking at how to solve it is an exciting challenge. I'm glad to have read this paper.
All right, next up from me, DIN Rails for Everything is a video by Maker's Mashup. He's using DIN rails, which are, I guess here in Europe, we use them for mounting our circuit breakers and things like that on. It's a metal rail shaped in a particular specified shape, and he's using these for racks, for mounting points, for all sorts of kind of infrastructure in otherwise 3D printed projects. So in some of them, he's got a 3D printed frame that supports the rail, and then he can clip his motor driver board onto it, and he can clip a stepper motor onto it to make a simple testing stand. Basically, the idea is with DIN rails in the middle and the power of 3D printing, you can just clip whatever kind of crazy ad hoc industrial test stand together you need to. And I love that. I think 3D printing and standardized size metal things are a match made in heaven because 3D prints aren't really that strong. I mean, certainly not as strong as steel. And you can buy these rails in standardized sizes. So it makes it super easy to design around. So the 3D print design is easy, the rail is strong, and the world is your oyster.
So can you go to the home store and just buy like any different lengths of this that you want in Europe?
Certainly here you can. It's what we've got downstairs in our breaker box, and yeah, you go to the electrical section and buy it by the meter.
This is really good. I love this kind of modularity. So we've seen those CNC machines that use the conduit as like a pipe, that like a rail that they could go along. Like this idea that you have this mass-produced, economies of scale thing that's available in your town, not at a specialty store if you count the home store. But really, I mean, I could go to, 3 dozen places in town and get conduit, I would think. So I really like that. And it cuts down on the amount of time that you're dealing with the 3D printing, because if you already have like a set library of ways to connect to the rail, it like supercharges your design process, and since you're not printing everything, it makes the actual print itself faster too.
And cutting out that design part is the real win here. I'm not sure that it's true of all of them, but I think Maker's Mashup did not design the majority of these parts here. I think he was just like, okay, I'll use this one. And he has an example where he has a 3D printed NEMA 17 motor holder of his own design, and he just puts 3 holes in it, and then he uses someone else's DIN rail clip design and puts 3 holes in that and just basically screws the 2 things together. So it's got all sorts of flexibility that way. And I do think that this kind of rail and maybe some rods like conduit and a couple other standard size things make the world a much easier place for people when they're doing this kind of large design. We've seen a few DIN rail 3D printing hacks before. One of the ones that stuck out for me was TDer was putting a DIN rail up on his or her bench and making a bench power supply that could clip in there, and presumably all sorts of other equipment holders now in the intervening years. That's a lovely application. It's kind of the obvious application. I mean, that's what these things are made for in industry. So here we are doing it. But it makes it super easy to do this kind of, real clean install at home. And I can't remember who it was to save my life, but someone came up to me at the Hackaday SuperCon 2 years ago now with a Raspberry Pi cluster computer where each of the different Raspberry Pi slices was on a little DIN clip, and they were all clipped onto this rail. And it was just this little desktop, absolutely beautiful, self-contained thing. Really, really pretty.
We saw a discrete 555 timer this week that was built from incredibly tiny components. It's the creation of someone that goes by the handle Robo. And I really liked it that when Chris Lott wrote this one up, he did kind of drill down into how difficult it would be to do the assembly on this. It uses 01005 passives, and it uses a special dual flat pack, no lead or DFN packages for the transistors that are on this. And it came in, it's a cute little thing. It's just one row on the breadboard wider than a DIP package would be. So the actual circuit board looks square, whereas if you think about an 8-pin DIP package, it's more rectangular. Obviously, it's some nice work, but the thing that was more interesting to me and I spent a lot more time on is that Robo did a subsequent article on looking at the dies of all of the different chips from different manufacturers that are sold under the 555 moniker. And Elliot, there must be 10 or 12 of these there.
And the 555 is not just the 555. Some of them have different thresholds, some of them have different tolerances. They must all have different layouts internally too, right?
Yeah, and it was interesting to hear his thoughts on it. The nice thing about this is it's so few different types of components. So like in the discrete version of it, it's just 2N3904s and 3906s for the NPN and the PNP variants. So really common, I'm betting you have those in your parts bin if you're into electronics at all. Really common transistors for that. And so when you add just a few resistors to those transistors, it means that the discrete design is simple because the silicon design is simple as well. And so even if you're not used to reading the different structures that are on the chip, it's really simple to get the hang of it. And especially because Robo did it with the same design as Hans Kamen-Zind in 1972. So he took that circuit and he labels the die shots in exactly the same way. So I spent a lot of time just like looking back and forth between the original schematic and then the labeled die shot, like figuring out where things are going. Some interesting tidbits on it. He talked about one design that looked like it was made for better operation, but then the published specs were exactly the same as the original 555. He looks at a TI part that seems to have been overhauled like around 2006. So it's like a completely new die design. And with that one mentions that like bonding pads on the die itself are interesting on this one because there are some that are in the center of the die rather than being around the edges. But it took up, I'd say a good hour of my time this week. I was fascinated. And before I knew it, I was like, oh, I gotta get back to work.
I have to say, you're a soldering ninja when you're making a discrete circuit and it's only a tiny bit smaller than the regular integrated circuit that you're replacing. But on the other hand, he could have just done this with a 555.
Oh,
I had to go there.
You went there. It was wonderful, Elliot.
Thank you. All right, my first quick hack this week is simple GUI menus in MicroPython. SGAL17A has written a very nice MicroPython library for you here. Basically, you define a bunch of tables that tell you what the menu items have to have, and then you give it the functions that you want it to run, and his library takes care of the rest. It's designed around an OLED and an endless rotary encoder and a couple push buttons, and makes the kind of annoying task of getting a menu system and doing all that data entry a lot easier. Next up, Stavros Korokitakis, the keyboard you really don't need or want. He was challenged by a friend to build a portable keyboard, and he came up with Keys, a 5-finger, this is like a million Ys, a 5-finger corded keyboard. And minimalist keyboards like this are one of the classic sources of hacker tears. Learning this cording system is fun. At the end, he has a beautiful log of how he designed it, how he built it. And then at the end, there's a video that's about 1.5 minutes long of him trying to type "Hello World." And it takes him about 40 seconds to just get the H. And he gives up with just writing hello. You know, you get to learn which one is the backspace key pretty quick. And he's like, come on, H, and just pressing random buttons. It's lovely. Last up, David Tucker, Air Assist Analysis reveals most effective and quietest methods. If you've got a laser cutter, one way to make it cut cleaner and deeper is to blow the smoke out of the way, and that's what Air Assist is for. You need some amount of airflow, but how much do you need? Well, that's a matter of science, and David does the science for us in this video here. He finds that a pretty beefy aquarium pump actually works for him. His compressor works just about as well, but it delivers a lot more air and is a ton louder, and so is maybe actually overkill. If you have a laser cutter and need to blow the smoke out of your way, you might be able to get away with a fairly solid aquarium pump. Check this video out.
I'm a sucker for a good persistence of vision display, and so when I saw this one by Jason Weave, I knew that I had to talk about it on the podcast. It does not use a row of LEDs like you would normally have. I think a traditional POV would have like a row of LEDs going back and forth very fast, and you light them up at just the right point to kind of make a display in midair. Instead, it has a Nixie tube, which is a vacuum tube with different shaped wire, like each of the characters that you're going to display 0 through 9. And in this case, it lights up that character at exactly the right point in an arc on a pendulum. The interesting thing for me is I didn't realize the response time could be so wonderful on these. You would think it would take a little bit of time for them to heat up enough to glow, but you can see in the video it works just perfectly. Next up, original Game Boy powered with a GBA motherboard. Now this one is actually using the Game Boy Advanced SP, which is one of those folding Game Boys, to put it into the original like large gray brick type of case. It is a lesson not just in cutting things down to make them fit inside of it, but you kind of get to work your way around these GBASP motherboards, which include fuses that can blow. They're not like automatic resetting, which is something new to me. It talks about making it chargeable. Like every different part of the peripheral that you might want to have on this handheld is covered in this project. And finally, a trip down the vacuum clamping rabbit hole. This is a project by Matthias Wandel, who I know as the person behind woodgears.ca. Matthias is down in the workshop making a clamp using the shop vacuum. So this is something where you put down a piece of plastic over whatever it is you're trying to clamp. You put the shop vac under it, it sucks all the air out and holds it very tightly all over the place for oddly shaped things. But he's having a little trouble getting the kind of the clamping tension that he wants. And so he puts 4 different barometric pressure sensors in different parts of this and then graphs it so that you can see like if you're close or far away from where that port of the shop vac is going, are you getting the suction that you need to? I liked it because it's just a really good methodical way to troubleshoot what's wrong with your clamping device. It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday authors. Elliot, what'd you pick this week?
This week, I picked Al Williams's Ask Hackaday, If Aliens Come By, Would We Even Notice? And this article was spurred by the Oumuamua object that did a close flyby of the Earth recently. I think a lot of people think it's a space rock, but it was hauling, and a couple people have suggested that maybe it was an extraterrestrial object, artifact, or even visitor. And this is not just crackpots. There's actually a professor at Harvard suggesting that we should at least consider the possibility that it was extraterrestrial and maybe a sign of intelligent life, because even though it's a super duper long shot, it would be so interesting if it were true. And so this is kind of turning the extraordinary claims require extraordinary proof on its head and saying kind of extraordinarily valuable potential scientific discoveries should maybe require a little bit more work in figuring out if they're true or not. It kind of clashes a little bit with my feeling about the philosophy of science, but that's not the topic here. The topic here is, but imagine that it was alien in origin just for a minute. How would we know?
Right.
And Al starts off here by saying, we can't even talk to dolphins. We know that dolphins are talking to each other. They live on our planet. We've studied them for quite a long time. They're not so far unrelated to us genetically. I mean, compare this to life on another planet. And yet we can't figure out what dolphins are necessarily saying to each other. How would we tell if aliens did come by in their spaceship and we just didn't hear them?
That's why we need to start our C-3PO project.
Oh, yeah?
Protocol droids could definitely take care of this.
I think that's probably true.
There's a Werner Vinge novel. Let's see, it's A Deepness in the Sky. And they're kind of like approaching a new species. And the thing that they want to find more than anything else is like an illustrated children's primer so that they can like figure out the culture and the language. And I think that that is an interesting way to look at it is like we have to teach ourselves what the cultural things are. We teach our children and it takes years and years and years, and there's still into adulthood all kinds of different interesting, gaffes and misunderstandings and this sort of thing. And like Al said, that's the same species. And so we kind of teach through our culture what vehicles look like and what communication channels look like. And I think that if you didn't come up with the same method of study, you wouldn't know. Like, you wouldn't know what things look like. And that's a really powerful point that I haven't really thought deeply about before. But if you have something that's buzzing by the planet and it doesn't look like a saucer, I think just dismissing it as some natural phenomenon does seem like a mistake. I don't know how you would go about. I mean, you can't send manned missions to Oumuamua, right?
I think it went by so fast that we would not have been able to get up there in time. Yeah.
Yeah. Because even if you crashed a probe onto it to try and take a sample of it, like there could be a technology where the spacecraft itself is burrowed into some asteroid and then been launched as a solar sail out that way and is using the asteroid to protect itself from, micrometeorites.
Right. Or. I mean, we see so differently from like bees. When we look at flowers, it's not what a bee sees when they're looking at flowers, even though we're all looking at the same thing. They see with different wavelengths. Maybe I don't know. I have this one horrible idea. Okay, here we go. This one's a stretch. Hold on to your brain caps or take a hit off your bong here, ladies and gentlemen.
I'm holding tight. I'm ready for it.
I was reading this one about aliens at the same time as I was doing some reading on some kind of heavy quantum mechanical phenomena. And I was thinking about what we humans think of as the wave-particle duality, which is when we see these phenomena, we say, oh yeah, look, that's like the kind of matter I'm used to. That's like a particle. Or, oh, look, that's having these kind of interactive phenomena like we're used to with waves. But we're not seeing in any real sense the reality. We're seeing these kind of two different ways that the reality behaves. And we're saying, oh yeah, we can compare this with this and we can compare this with that. What if the aliens see through quantum mechanics and they actually perceive the world as it is? Would we even be able to communicate with these things?
Yeah, that's harder for me to think about. I mean, more like the two-dimensional beings versus three-dimensional beings. That's an easier thing because we might be seeing them straight on, in which case they have no depth in that third dimension, and so we see nothing. But yeah, I get what you're saying there. And I think that Al's dip into this like test pattern that was sent out, Drake's Arecibo message, where you like look at it and you say that is, it's a pixel pattern that resolves into an image. And I think this one that's shown in the article is what he's talking about having sent to a bunch of different researchers throughout the world, right?
Right.
He sent it out to like well-known, I think, research professors, and like only one of them figured out that it was an image. Again, his point that it's very easy for our own species to totally miss the message.
This was the best case scenario, and it took, 1 out of 100 people were able to decode it. It makes me worry a lot. Anyway, I really love this one because I do think that, how we would communicate with aliens is like, it's simultaneously both kind of a Rorschach test about what we think aliens might be. You're like asked this question that's basically unanswerable, and you start making up these things. Like novel writers, like sci-fi writers, like the one you mentioned, are like, oh, we need to find children's literature. Why are you saying this? Oh, it's because you're a writer and you value literature. Like, it's also kind of a mirror on ourselves to think about how we would talk with the alien. And that's what's always fun to me about sci-fi movies, where they take on this question. But not fun to me about Star Trek, where they're like, oh, the Klingons are hailing us. Oh, hey, mortal enemy and crazy different species. How's it going?
For our second Can't Miss article of the week, we have a special treat, a special guest this week. She has been writing a wonderful series on Hackaday for the last couple of years called Inputs of Interest that covers all things keyboard, mice, and otherwise human connected to computer. Please welcome to the show Hackaday staff writer Kristina Panos.
Yay!
How you doing, Kristina?
Great. It's good to be here. Thanks for having me.
I have to say, Mike, I think we have you in the minority here, because I have in front of me a strange clicky keyboard, and I'm nearly certain that Kristina has a strange clicky keyboard in front of her.
Or 2 or 3.
So yeah, what are you two typing on these days?
I've got that Kinesis Advantage still. It's kind of ugly, but I don't really care. And I don't mean that because of the way it's shaped. I mean, it's 20 years old and it's like tan ABS. It's all yellowed. But I mean, I love it. It's a great keyboard. I sometimes miss my 10 key, but really it's a fantastic keyboard, and it's pretty much saved my arms, I think. Feels like it.
That's fantastic. I know everybody I've heard who really gets into that keyboard never goes back. I'm scared myself.
So it looks like you talked about that keyboard in your ergonomics article way back in March of last year. Is that one of the reasons that you got into all kinds of different keyboards?
I would say so, yes. Really, I mean, I've always liked weird looking ones and ones that feel nice. My first experience with one was either in a Barnes & Noble or a Borders a long time ago, and they had the customer search thing, and they have a little Cherry keyboard. I was like, wow, this keyboard's really great. I picked it up and looked at it. I said, Cherry, okay. And that was my first brush with Cherry, and that was probably in the early 90s. But I mean, back then, I don't know how people got Cherries, but you couldn't just go to the store and get one, it seemed like.
Right.
And then this one where the keys are actually like on the inside of an orb almost, right? They're concave away from your fingers in order to be like equidistant for each digit.
They are. They call them key bowls.
Key bowls?
That is the trademark term, probably. This keyboard does a lot of things to help you out. The key heights are different from key to key, just because like pinkies are shorter than index fingers, and people have put, and I'm considering doing it, put uni construction keycaps on like DSAs that are all the same height and profile. I think that looks really good. I think it might take a little bit of adjustment to get used to, but I don't think it would throw me off as long as they fit everywhere.
The other one of those, like, once you experience a blank in keyboards, is the non-staggered layouts. And like some of them are ortho, where they're shaped like basically just a grid. And then you can take that grid and then split it in half. So you can then, get 2 grids, one for each hand, so that you don't have to do that kind of awkward thing with your wrists where you pull your wrists in. And then you can stagger them up and down, I guess, to compensate for the fact that your fingers are all different lengths, like Kristina was saying. And that's what my keyboard does. And man, once you start down that path, you really can't go back, I think. It's just so much more comfortable. On the other hand, then it makes typing on normal keyboards a little bit hard, but it's not half as hard as you'd expect in my experience. What do you think?
I would agree with that. The biggest problems I have are hitting the spacebar with my left thumb because I think I'm hitting backspace.
Yep.
And going back to hitting C with my index finger because I just can't seem to hit it with my middle finger on a staggered keyboard. I don't know.
Right. My current one has a lot on the thumbs. I have like shift and escape and control and backspace. And so my thumbs are doing a lot of like dancing around. I know you have to be doing that too. But it's true. You try to backspace and bam, that's the space bar on a normal keyboard.
Do you have a dactyl?
I've wanted to print one out. I've actually printed one out. I've printed two dactyls out in terms of just making a mock-up to see if I had the right number of keys and the right layout for my fingers. I'm not a big fan of the thumb cluster on the dactyl, but the rest of it seems super awesome. Did you end up making one in the end?
I did. Yeah, I did make a dactyl. It is physically complete. It is not in complete working order. Half of it works, and I just kind of put it away for a while so I wouldn't end up throwing it in the trash.
What got you? Was it the wiring?
I think so. I've done a pretty thorough continuity check, and it seems to pass. But I think the side that doesn't work, I'm just going to get a new Pro Micro and start over. I used stranded wire because I didn't fight hard enough to find really thin solid core.
Yeah.
So I think I'm just going to redo that board and try not to cross the streams.
I'm going to go look at yours right now. Did you go with... Oh, you did go with number keys and everything. So it's a 5x6 or whatever.
Yes.
Yeah, that's the way to do it. So my current keyboard is I made it just as a temporary travel keyboard and an experiment with ergonomic keyboards. And I've used it now for 2 years because it's really okay. But 48 keys, it's set out like an Atreus, if you know that one. But that's just too few keys. I need all the other keys. I want more keys. I want 1,000 keys.
1,000 keys? Yeah, you need a kanji keyboard.
Yeah, exactly. I want one key for everything so that I can just press that one key. Because, I don't know, I use a lot of function keys, right? And they're all, on modifiers. And I don't know, 3 modifiers for your function keys? Please.
No,
Please.
thank you.
So you've done a lot with other designs as well. Like you had a split keyboard design that was the same circuit board, just transposed on top of itself. What was that one all about?
Oh, that was the ErgoDocs kit that I built. I hesitate to call it a kit, but if you get all the parts together, then it becomes a kit, right? If you don't. So yeah, somebody designed that board and they made it so it's one board and you just flip it over for the other hand. So you can make a one-handed one if you want. And you don't have to deal with printing out 2 mirrored PCBs or having them fabbed.
That's pretty clever.
That ErgoDocs, man, and I've heard this from other people, it's just too big. I think it's the flatness, but my hands are just not that big. I can't reach the thumb clusters as well. It looks great, of course, but it's just too big. I can't use it.
I actually printed some out on paper just to see how it would feel when I was typing around. And that, by the way, if you're designing your own keyboard, that is the best thing to do, is start with just printing out paper and then print out the 3D models, but don't populate them next if you're building something wacky like a dactyl. Just printing it out on the paper, I could feel that I was going to have to stretch for some of those thumb keys.
Now, see, that makes me want to make a whole paper mache mock-up.
Ooh.
Yeah, right?
With curves and angles. Absolutely.
Huh. Yeah, that would be interesting. Would you 3D print a mold for that and then paper mache into the mold?
No.
Nah.
But I could
Paper mache it straight up.
Yeah, paper macheing it straight up and then scanning it in to print it.
Ooh, to get the model. That's cool.
Ooh.
Yeah.
Now I'm jealous.
It's all within your grasp.
I think the most recent project that really caught my attention is you sent over a picture of a keycap that you built that was a Samore.
I'm surprised that you that's my least favorite one. I don't think that one's very good. I did the top graham cracker disappoints me. It's not thick enough. It's not uniform. I didn't get the holes right. Yeah, and it could be better.
No, the Twinkies are outstanding.
Oh, thank you.
The taco's pretty funny. So I've seen a bunch of these art keycaps before, and sometimes they'll put them in resin, so it's like normal keycap shaped, and then sometimes they're just basically sculptures sitting on a keycap, which is what yours are like.
Yeah.
How do you type with those?
Well, the idea is not to have a keyboard full of sculptures, though you certainly could if you wanted. Especially for some of my very tall ones, like the cookie stack.
Right.
I envision those being on a keyboard that has escape up there, like as an island.
Like a function key you don't use, or...
Yeah.
Yeah, I could press those every once in a while.
Because I don't know if you remember the old Panic keys. Those were like my first brush with keycaps a long time ago. I had a red DSA Panic key that I couldn't use because it had a cherry profile and I just had rubber dome keyboards. But I had it like on a blank space in my number pad just so I could look at it. I don't know.
Well, when you're Panic, it's good to have a Panic key.
Yes.
You need the any key, right?
Yes.
Where's the any key? It's a deep cut.
Press any key to continue.
I think I had a very old computer, like a 386, that was full of Simpsons quotes and sounds when stuff went wrong. Yeah, those were the days.
What's the next keyboard on your list?
For the column?
No, just for general keyboard acquisition syndrome. What is the next keyboard? What have you got your eyes out for when you go trolling eBay?
Right. Do you have a white whale that you'd really want to get your hands on?
I mean, I want a data hand pretty badly, but they're like $2,000 minimum. I should build that I don't know how to say it, Lal board that Jesus Freak made.
Was that the one that was like the pseudo data hand?
Yeah, the open source brown one.
Yeah.
Thing's amazing. Other than that, there's an IBM that separates. That would be cool to have. Like I think it goes from a rectangle to like a split. Really just anything crazy that I see that catches my eye. As far as like I'm not interested in acquiring keeb after keeb to use because I just can't. I've got to use a split. I've got to use this. I've got to use that. I don't have the time to mess with different layouts really.
Yeah.
But acquisition roundabout wise, man, anything that catches my eye, really.
Sweet. Well, I think we all know about the next one up in the series, so we could spoiler it.
Nah.
Stay tuned to Hackaday for more in the Inputs of Interest series.
Yeah, so we have a link to that Inputs of Interest series up on the show notes, and there's 15 or 16 entries in there so far. There's a couple other links in here. I really enjoyed, Kristina, your greatest keycaps and where to find them article. It kind of rounded up the most interesting things that people were doing. So check that out. And staff writer Kristina Panos, so great to have you on the show today.
Well, thanks for having me.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you've seen something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking. Hackaday employees and their relatives are not eligible for the something. What did I even pick? Korokitakis.
Do you think we should jump right into news?
Sure.
Yes.
What kind of goofy rhetorical question is that? Of course I do.
Oh my gosh.
My gut says it's going to be fine.
Whatever. It'll be fine. Cool. That's it. We're done with the show. Let's close it up.